question number 12, I want you to position and label an isosceles triangle with base AB of A plus B. So what I'll do is I will put A at 0, 0, and I'll go to the right A plus B. And that's why B is going to be to the right A plus B and 0. Since it's an isosceles triangle, I'm going to put C someplace up here. It's going to be halfway between 0, 0 and A plus B. That's where we get the x coordinate is going to be A plus B divided by 2. And what you call how far up it goes doesn't really matter. I labeled it C. You could label it whatever you want and be correct. Okay, on number 4, why are these triangles congruent? Well, notice I've got a right triangle. The hypotenuses and the legs are congruent, each one. So that reason would be HL. Don't have to do any work on that one. Okay, number 15. We do have to do some work here. I want you to find the measure of all these angles. Well, the first thing I notice is I've got a linear pair right here. So 107, so angle 4 then is going to be 180 minus 107. 180 minus 107 is 73 degrees. Notice angle 4 and angle 5, they're vertical angles. So angle 5 is 73 degrees. Now 5, 65, and 2 make a straight line. So to find the measure of angle 2, I'm going to take 180 minus 73 minus 65. Well, I'll work my way across. 180 minus 73 is 107. I take 107 minus 65. 7 minus 5 is 2. And 10 minus 6 is 4. So I get angle 2 is going to be 42 degrees. The measure of angle 3 is an exterior angle. So to find the measure of angle 3, I'm going to take 42 plus 90, which would be 132. So the measure of angle 3 is going to be 132 degrees. Then, to find the measure of angle 1, I'm going to use my triangle sum theorem. That is, I know there's 180 degrees in all three triangles. So I take 180 minus 70 minus 73. 180 minus 70 is 110. I'll subtract 73 from that. 10 minus 3 is 7. 10 minus 7 is 3, so the measure of angle 1 is 37 degrees. I'll do the same thing to find the measure of angle 6. So the measure of angle 6 is going to be 180 minus 107 minus 43. So 180 minus 107 is 73. Minus 43 would give us 30 degrees for angle 6. And there are all your angles for question 15. On question 16, I've got triangle JGO is congruent to our WI. I want to know what corresponds to I. Well, it corresponds to I. I is the last letter, so that would be O. So that's just O. On question 17, can you draw two triangles that have all three angles congruent, but that are not congruent? Sure you can. Easiest way? Draw two triangles that look together. One is bigger than the other. Okay, so can I prove can I use angle? No, I can't. Must these two triangles be congruent? Number 18. That's very similar to what we've done before. HL. Yes, they have to be congruent because of HL. Because it's a right triangle, so we can use HL. Didn't have that right angle, it might be different. Okay, question number 19. I want you to position and label in the coordinate plane right triangle DJL with a hypotenuse D and J, and LJ is going to be half of DL, and DL is A units long. So my hypotenuse is D to J, so, and then I want L to J to be half of D to L. So what I'll do is I'll put L up here. Actually, let's put L right there, because I want my hypotenuse to be D to J. So I'll put D up here someplace. And then, so D to L, I want L to J to be half of D to L, so I'll put J like right here. And then it tells me I want D to L to be A units long. That means L to J would be 1/2 A. So the way I'll do that then is D is going to be at 0 in A. J is going to be at 1/2 A in 0. Okay, my next one, I'm going to have my coordinate grid. I know A is at -1 and 1. Let me change the colors here. So A is going to be at, whoops, -1 and 1, not -1 and 0. Let's try that again. So -1 and 1 is going to be A. B is going to be at 5 and 1. And C is going to be at 2 and 6. Now show me this is an isosceles triangle. Well, it kind of looks like it might be, but looks are kind of deceiving. Let's do this. Let's find A to C. So we're going to use our distance formulas from A to C. So I'm going to say 2 minus a -1 squared plus 6 minus 1 squared. So I'll get 3 squared plus 5 squared. 9 plus 25 would be the square root of 34. That does not simplify. Now let's find B to C. So I'll go 5 minus 2 squared plus 1 minus 6 squared. That'll be 3 squared plus -5 squared. Oh, look at that. That's also the square root of 34, isn't it? We have two sides equal, so it's isosceles. Okay, and on 21, we want to name our congruent triangles. You can start whatever you want. I'll go K and M. I'm going 1 to 2 to the unmarked. So that would be congruent to KLM, 1 to 2 to the unmarked. You could have a variation of that answer, but that's what we're looking for. Now, we've got this triangle, two triangles actually, ABC and PQR. And we want B to be isosceles. And I know they're congruent, so I didn't draw that out very well, so let me try that again. Doesn't look very isosceles to me, but or very obtuse to me, because I want angle B to be 154. And the only, if it's isosceles, it's got to be the vertex angle. So I'll go A, B, C, and I'll go P, Q, and R. So I want to find the angle R. Well, I know the measure of angle R is going to equal to the measure of angle C. So I'm going to find C first. So I take 180 minus 154. And then I'll take that answer and we'll divide it by 2 to find the measure of each angle. So 10 minus 4 is 6. And 7 minus 5 is 2. So I get 26 divided by 2, which is 13. So angle C is 13, which makes angle R 13 degrees. Now if I take a look at question 23, why are these two triangles congruent? I see a right angle, so I know angle B has to be congruent, or the two angle B's have to be congruent. ABD is congruent to CBD. And that makes me think of HL. But HL isn't a choice. But I do have AB and BC marked congruent, and I know BD has to be congruent to itself. So really I've got side, angle, side. And that's our correct answer for 23.